Assalamu alaikum wa rahmatullahi wa barakatuh and a very good day. This is our video for our engineering mechanic final project, code BDU 10503, Group 1, Section 3. Now let's get into it. Now, in this video, we will introduce ourselves, show you our problems and solutions, lesson learned, and also difficulties and action. Now, to start off, let me just introduce myself and my group members. My name is Ahmad Mohsin bin Sazali, CD 190113.
My name is Muhammad Adli Zufairi bin Shamsul, AD 190117.
Hi, my name is Muhammad Hanis bin Hairuddin, metric number AD 190002.
This is the problems and solutions. Now, this is the first problem. Support reaction. Search for the support reaction at A and B. Now we have calculated, and FB is equal to 3.464 kilonewtons, and the reactions at A direction X is 1.732 kilonewtons, and the reactions at A direction Y is 1 kilonewtons. Now this is the solid work analysis. Now at support A, we got the same answers at Fx and also Fy. And also at support B, we also get the same answers. Refer to the F resultant, 3.46 kilonewtons.
Next, for the static problem number 2, it's regarding structural analysis. We need to search for the force at each truss. The picture on the right is the question for this problem, and the picture on the middle is the free body diagram at the joint D, joint B, and also joint A. Next, for the manual calculation, we start at the joint D. At the joint D, we can find the force for the DC truss. And also, at the joint D, we can find the force at the DA truss. Next, we go to the joint A. At the joint A, we can find the force for the AB truss. And after that, we go to the joint B, where we can get the force for the BC truss. However, there is one truss that classified as zero force members, which is the BD truss. Next, for the SolidWorks analysis, for this problem, we can get the force for each trusses from the SolidWorks itself. So, this is the force for each trusses. The force is the same like a manual calculation.
Dynamic problem. It is related to projectile motion. We need to search for the distance traveled, the value of r. Given the initial velocity at a certain angle, VA is equal to 50 meter per second, and the height for the launch place is 50 meter. First of all, we need to resolve the initial velocity into x and y component. Vx is equal to 12 meter per second, and Vy is equal to 9 meter per second. We can get the time travel from Sy is equal to Say plus Vayt minus half gt square. So for the value of time travel is equal to 2.8922 seconds. Lastly, we can get the value of r from Vx times t. So the value of r is equal to 34.71 meter. The value for SolidWorks analysis obtained is approximately same as the manual calculation, which are t is equal to 2.89 second and r is equal to 34.71 meter for the manual calculation.
Now, let's get into the lesson learned. The first lesson is extracting results and data. So basically, SolidWorks is capable to create and extract results and data based on the analysis.
Excellence in SolidWorks motion study. SolidWorks allows the study of motion with different components under different input conditions. In this assignment, the motion analysis is mainly used to execute the result. In addition, in motion analysis, the velocity is able to apply into it, plus the addition of gravity is useful for projectile motion study is also learned in the motion study. Lastly, result can be generated from preferred preference based on assigned problems and can be exported to Microsoft Excel to further analyze the data.
The last lesson learned is the final answer accuracy. SolidWorks software gave us more accurate answer compared with the manual calculation. This is because SolidWorks software did not neglect any important detail that needed for them to conduct the analysis. So it will give the final answer more accurate compared to the calculation that done by a human.
Now, let's look at difficulties and action.
The difficulty in simulation is did not meet the expectation. We're expecting that the ball will launch and bounce on the launch base, but the real is the ball is turning around the launch point. So the action taken is find the problem and do again the simulation. The problem is the coincident point between the bottom point of the ball and the launch point need to be deleted so the ball can be launched.
So, for the next difficulties and action taken, it's regarding communication. Online distance learning limit the discussion among group members. So, the way we overcome these difficulties is by using platform Google Meet and also WhatsApp to communicate among our group members. By doing this, we found that the communication between our group members is quite good and we finish the work on time.
Thank you for watching.